So in this example, let us see how to find center of gravity of another compound section. So the compound section is as shown in the diagram. Say this height is 150 mm, the width is 25 mm, here the length is 100 mm, here the height is 40 mm, and it is located at 20 mm from the top. This section is located 20 mm from the top. So to find the centroidal distance x bar, first we need to divide the compound section into two simple sections. So let the compound section be divided into two rectangular sections. So rectangular section 1 and rectangular section 2. So as soon as we divide, we need to mark the dimensions clearly. So the dimension of element 1 will be 150 mm and width is 25 mm. Similarly, the dimension of element 2 will be 100 mm width and 40 mm height. And we need to choose a reference axis for finding x bar. So let the reference axis for x bar be chosen at the left end of the compound section. And we know that x bar equal to a1 x1 plus a2 x2 divided by a1 plus a2. a1 will be this horizontal dimension is 25 into 150. So 25 into 150, 3750 millimeters square. x1 is the horizontal distance from the reference axis for x bar to the CG of element 1. So this distance is x1. So this will be equal to, this is 25. So therefore 25 divided by 2 will be this x1. And a2 will be this 100 into 40. And x2 will be the distance from the reference axis for x bar to the CG of element 2. So the clear distance available is this 25 mm plus this 100 divided by 2 will be the distance x2 as marked here. So from here to the CG of element 2. So this 25 plus 100 by 2 will be x2. And if you substitute these values, a1 x1 plus a2 x2 divided by a1 plus a2, you will get the x bar value. And x bar value will be 44.76 mm from the left side of the section, since we have chosen the reference axis at the left side of the section. Now to find y bar. So to find y bar, the reference axis for y bar shall be chosen either at the top or at the bottom of the section. Here we have chosen the reference axis for y bar at the bottom of the section. So y bar equal to a1 y1 plus a2 y2 divided by a1 plus a2. a1 will be 25 into 150. y1 is the vertical distance. As we say, x1, x2 are horizontal distances. y1, y2 are vertical distance from the reference axis for y bar to the CG of element 1. So from here to here, this is y1. So y1 will be 150 divided by 2. Then y2. y2 is the vertical distance from the reference axis for y bar to the CG of element 2. So from here, this is y2. So y2, to find y2, we need this clear distance. We need this clear distance. So that can be found using this 150 minus this distance is given in the problem. So that distance will be, say from the top, it is located at 20 mm. So 150 minus 20 will be 130. 130 minus again that 40 will be 90 mm from the bottom. So this 90 mm from the bottom. Okay. Total 150. So minus 20 minus 40. So this will be 90 mm from here. Therefore, y2 will be this 90 plus 40 by 2. 90 plus 40 by 2. Therefore, y bar equal to a1 y1 plus a2 y2 divided by a1 plus a2. So this will be 93.06 mm from the bottom. So this is how we should find the center of gravity of compound sections.